Okay, Aldo, go ahead.
Yeah. So me, Aaron, and Tony were working on integrating OpenMCT and ROS2 to NIX. It's still work in progress. So, for example, here we're building now the OpenMCT package. Eventually, it will be able to build with plugins. So if we look at, sorry, this is not the right place. Yeah, so this was OpenMCT. The other one is the NIX-OS play right now. And you can see here, this is kind of how it's going to look like in the future. So we're using ROS Iron, ROS Qualcomm right now. And I'm missing here my package. I don't know what happened. Let's see. Next develop. Yeah. So basically now we have ROS2 run, and you can see the ROS packages right now. It's a heartbeat that I'm running here. And you can see ROS2 run demo node, a listener. And here it will be the heartbeat itself. That kind of restarted. So it's still work in progress. There's not too much, but that will allow us to develop either ROS2 nodes or OpenMCT plugin faster. So again, I'm trying to figure out what happened to the heartbeat here. I had it here. Okay, I made some changes. But I need to do a lot of cleanup, and then I push it. And it will be as easy just like adding the plugin and work with it. The plugin right now lives in this was right here. That's the plugin itself, and there is all the make files, and of course the NIX itself of how to build it. So this is the heartbeat ROS2 node. So basically, when you develop a ROS package, you will need to create this default NIX in a folder, and we will be able to include it here. So it should be something like that, heartbeat.
Mm-hmm.
Yeah, but I deleted it, so I need to figure out where it disappeared.
Mm-hmm.
Yeah. And besides that, we did some work on the recorder, but it's not ready for demo yet. But we have it working. I would say about 30-40% of it is working with somewhat good performance. What else? Yeah, that's pretty much it.
So,
Yeah.
may I ask you just to understand what we see here? So you have a listener and a heartbeat. The listener is to the left and the heartbeat is to the right. The listener is
Yeah.
receiving updates every 0.1 seconds, and the heartbeat
Yeah,
is
so
every
the
0.1
heartbeat is
seconds.
generating. Yeah, the heartbeat is generate a loop every like in 10 hertz on ROS2 as ROS2 messages, and there is a listener that just listens to it.
Mm-hmm.
It's we probably will use it just to detect kind of slowness on the system or whatever, but it's not like a main core node. We have the main core node that Fabio wrote before and some others. But eventually, once we have the build system on NIX working, we will just be able to use it and kind of migrate it to NIX. And that's like the camera driver that he wrote, and then the GPS driver that I wrote. We can migrate them to this. And then it will be part of our system build. So right now, I can show. If we look at, let's say, my flake. So this is kind of how we load ROS2. Here it is. No, actually, that doesn't work. But it will be something like that. How to enable the service of the heartbeat, how to enable the service of ROS2, and then different plugins, like Sky360 plugins. So this is something also that I'm working how to deploy everything to a system. That's another thing. Yeah.
Mhm.
But all of it is kind of, I work on 3 different kind of stuff in parallel. So it's ROS2, OpenMCT, and then how to run it on the SD image itself.
Yeah. So basically, the
Yeah.
heartbeat C++ code is something that we could use as a template for new developers to start with, to have a basic construct that they can
Yeah,
build upon.
exactly. So it will be the NIX and the stuff, and eventually we'll create a NIX template that you can just say, hey, I want to create a Sky360 node in C++, and that will generate everything that you need, including the OpenMCT plugin
Mm-hmm.
and the ROS2 plugin.
Mm-hmm.
So you'll be able to run it and test it. Yeah.
Mm-hmm. Could we make this structure somehow on GitHub so that new developers can pick it up from there
Yeah,
easily?
it's not ready yet, but once it's ready,
Mm-hmm.
we will it will be
Yeah.
on
Okay.
GitHub.
Mm-hmm.
Yeah,
Cool.
yeah. Right now, I think the only thing in GitHub, no, it's not even that. Even the OS2 is not there yet.
Mm-hmm.
It's on my fork, but I didn't push it yet because I want to complete it and then have a proper pull request with everything.
Okay.
Yeah.
Cool.
Mm-hmm.
Any questions? Or am I the only one? No questions? Hey, Yannick.
Hey,
Hey, Yannick.
I don't understand enough, honestly, about Nix and still also Rust 2, so I don't have any questions yet.
Yeah, maybe I'll explain it a bit. So
Okay.
Nix has multiple meanings. First of all, there is Nix, the functional programming language. Then there is Nix, the package manager that utilizes the Nix programming language to build packages. And then there is NIX-OS, which is an operating system that is being built using Nix, package management and Nix programming language. And the idea here, if we look at, let's say, Sky360 NIX-OS, so basically I defined inputs. So for example, Nix package zeros, this is not important. The board that we're using, which is the Orange Pi 5, Orange Pi 5 Plus. And then I have a function that receives the inputs and convert it to outputs. So for example, to build the Orange Pi 5 Plus, a configuration, it's basically an ARM architecture. I'm loading the Orange Pi 5 Plus module. I'm loading the base module that we built, and here it's the Cyclope, right, which is the all-sky camera. I set up the host name, and I set up the image name for the SD image. So what I can do here is basically Nix build. Sorry, I forgot a command, but I think it's in the make file. Yeah. So if I run this command, right, that will start building. And again, right now I'm working on it, so it will not work. I have some changes. Yeah. Oh, I actually misspelled the names. Yeah, it's dash. Yeah. So you see now it will start building the SD image. Download whatever it needs and all of that. And what's nice about it, about Nix, that it's built a reproducible build. So every version of every package here that I'm using has a hash. It built it. So if I look at result right now on the SD image, you can see it here, right? 1.1 gigabyte, and here's the ZST, the compressed image. Okay. And what's nice, I can build it to multiple hardware. And again, it's reproducible and version locked. So if you run this command now in your system, it will be the exact same image with the versions of every dependency that you have, including drivers, including whatever. And we're building here like our own kind of operating system variation of NIX-OS with what we need, with the modules that we need. So that's NIX-OS. ROS2 is called a robotic operating system. It's basically both a development environment and runtime for robotic parts, and it uses a middleware for communication between all the robotic parts based on what's called DDS. DDS is a data distribution service. It's a known protocol for real-time system. So what you see here on the bottom, the heartbeat, it's basically I'm publishing a topic, a ROS2 topic on one node, and then another node is receiving it. So it's a way to develop, again, publish subscribe. It's based on event-driven architecture. So it's about publishing events and receiving events and handling those events in a reactive way, the same way as a robot will react to a change in the situational awareness of the components. Okay, Yannick?
Yeah, thank you. I have somewhat of a high-level understanding of ROS2, but when it comes to the details, yeah, I'm still lost. So
yeah, that's okay.
but thanks. Yeah.
So
I understood what the heartbeat does, for example.
Yeah. So if I show you the heartbeat a bit more. Like here, so this is like just I took like the normal kind of talker listener of ROS2 and kind of converted it to a heartbeat. And that's why you see here still demo node CPP and all of that. But basically, I create here, you see like a timer every 100 milliseconds, and I call the function publish message. And the publish message, really what it does, you just get a data message called loop with the count and publishes it. Really nothing much. And of course, write stuff to the logger. And we don't need here any quality of service or anything because we want message to be lost. Because if we lose the loop message, you lost the heartbeat in the system, right? So it's just like a nice way to kind of debug stuff to see where there is slowness. If there is a slowness in the system and you're losing messages on something that is not trivial. Because sometimes when you work on like real-time stuff, if you put too much quality of service everywhere, and you start to have bottlenecks, and it's kind of hard to know where. So this service will allow us kind of look at that. But there are ways, for example, here you see that you can keep the last 7 like, kind of in history. So if someone is requesting the last X state of the heartbeat, they can receive it. Actually, it's this one. This is 10, whatever. Yeah. There's some note for me here that I need to change. There's really not much into it. It's very basic kind of node. The reason I wrote it is because, again, it's nice to have it, and I needed like a fast node that I can build, again, all the NIX development, build, and deploy around it. And right now we have the build. I'm working on the deployment part, which means I want to have now the heartbeat run it part of inside the SD image. So when you put the SD image, the heartbeat will start working with it. Right, and that's kind of the next step. And of course, also the OpenMCT will run with it. So we'll be able to go to the IP address of the Cyclop, like the fisheye camera, on port, let's say 80, whatever, and then see the OpenMCT browser loading the heartbeat plugin. So you can see the plugin kind of working on the UI. So that's what I'm working on right now. The moment I'll finish that, we'll be able now to replicate ROS2 nodes and OpenMCT plugins really, really fast. And finalize Aloha is what we're after.
Cool.
Okay. Yeah. So that's where we are.
Okay. Great. Thanks, Ido. Thanks for
And
the
again,
summary.
the recorder is in the shadow right now, but we will demo it soon when it's more ready for a demo.
Okay. Thanks, Ido. Thanks for the summary.
Yeah. Absolutely.
Any other questions? Stop our recording for now.